Okay. Section R.2. Adjust this camera. Section R.2. So, what do we mean by real numbers? How can we classify real numbers? Well, first, there are the natural numbers. Our book will call them natural numbers, but a common word for those is the counting numbers. Unfortunately, they're not referred to as counting numbers. They call them natural numbers. They have a symbol, this fancy N. And the reason they say counting numbers, think of how would you count? You would start with the number 1. 1, 2, 3, 4, and keep going forever. So that's an infinite set. Okay. The whole numbers, the set of whole numbers is going to be all the natural numbers plus an extra one, and it'll be the number 0. 0, 1, 2, 3. So it's the counting numbers, but it's the 0 in there. Okay. So that's an infinite set. If they refer to an integer, then it's going to be the whole numbers but we also want the negatives. So think of the whole numbers and then taking a negative of everything. Okay. So -6 is not a natural number. -6 is not a whole number, but -6 is an integer. The number +6 is a natural number. It's also a whole number. It's also an integer. Okay. Now we come to rational numbers. So a rational number is any number that can be written in the form of the fraction p over q, where p and q are integers. Let's just get it written down. Okay, the definition. Let's just get it written down, and then we'll think about it. But let's not try and think about it while we're writing it down. Okay, so all of the natural numbers would also be rational numbers. All of the whole numbers would be rational numbers. All of the integers would be rational numbers because, well, 6 is a counting number. We all agree on that, yeah? But what's that fraction equal to? 6 over 1 is equal to 6. So if you put 6 over 1 in your calculator, it gives you, oh, sorry, let me clear it out. Gives you the number 6. So you can turn any integer into a fraction just by putting it over 1. So any integer is also a rational number. So -7, that's an integer, but it's also the same as that, isn't it? So it's also a rational number. Okay. The number 1/2 is a rational number. So anything that you can write as a fraction is a rational number. The number 1/2 is not an integer, is it? Okay, the number 1/2 is not a whole number. So the natural numbers, the whole numbers, integers, we don't have any fractions in there, proper fractions. When I say proper fractions, yes, the integer 6 can be written as a fraction, but you would never write it in final form like this. You would reduce it to that. But we're saying 6 is a rational number because we can write it like this. A rational number is any number that can be written in this form, P over Q, where P and Q are integers. Also, how can you tell if something is a rational number? If you have a decimal that ends, that terminates. So 1/2 is the same as 0.5. And so I don't have an infinite string. Now, I can have an infinite string and it's still a rational number because we all know that 1/3, that's a rational number. I've written it as a fraction. But the decimal of 1/3 is 0.3333, and it goes on forever. So I can have an infinite decimal expansion if there's a pattern to it, which there is on this one. Okay. So when is 1 not, so the number 1/8, that's 0.125. So if I just saw this, I would say, yes, that is a rational number because it's a decimal and it terminates. If I saw this, I would say, yes, that is a rational number because it does have an infinite expansion, but there is a pattern to it. That will be a rational number because it is an infinite expansion, but it does have a pattern to it. So it will equal some fraction. Okay. So what is a number that is irrational? A number that is irrational well, irrational numbers have an infinite decimal expansion and, it's very important, there is no pattern. So it's just random. And what would be a famous irrational number? It's used in circles a lot in geometry. You think of it? It'd be the number pi. Okay, so the number pi, now here's the drawback with this. Okay, that's better. The drawback with the calculator is this calculator takes it to 9 decimal places and then it rounds. Calculators can't do infinity, okay? So if I take, here's pi, right above this up arrow, we see pi there. So if I press the second button and hit this little up arrow button, you see you get the symbol pi. And then if you press enter, that is actually not the number pi. That is pi approximated to 9 decimal places because our calculator can't do it. And I don't know if you've seen these posters, but it'll have pi on it, and then it just goes on line after line after line after line after line. It goes on forever with its decimal expansion, and there is no pattern to it. But as I said, this number that they're showing us on the screen is not really pi, that's an approximation. And that particular number is a rational number because it ends, the decimal expansion ends. So we just have to keep that in mind that our calculator can't do infinity. So the square root of 2, so how do you tell? Basically, if it takes it to 9 decimal places on your calculator, that means that it is an irrational number that it has approximated. Okay, so the square root of 2. That's not really the square root of 2 because it's an irrational number. It goes on forever. It's decimal expansion with no pattern. But our calculator has rounded it to 9 decimal places. Okay, so if I try and do a third, it's 0.333333, but it goes on forever. And there's a pattern. So yes, and you can write it as 1/3. So instead of that, let's see if we can tell on this one. Okay. So here's a textbook example, and they've got it worked out for us. Let's look at the one in blue. So that's not printed in your book. This is my book, the teacher's book. Okay. So let's do the same exercise. Which of these are natural numbers? So let me get a pen that is, I can retract the ink and not mess up my book. Is that a natural number? No. The natural numbers are the counting numbers. And they start with 1. 1, 2, 3, 4, 5, 6, 7. So we don't have negative numbers, okay? So we had our list. So that is not a natural number. Is it a whole number? No, because the whole numbers are 0. 1, 2, 3, 4, 5, 6, 7, on. Is that an integer? Yes. Okay, it is an integer. So is it a rational number? Yes, because I can write it as a fraction. I can write it as negative 12 all over 1, couldn't I? So, and the real numbers is going to be everything. The real numbers is rationals and irrationals together. So it is a real number. All of these are real numbers. The real numbers are everything. Okay. Until we get to an even bigger set, which is real and complex. But we're just dealing with real numbers in section R.2. Okay, this guy. What kind of number do we reckon that's going to be? What's the most descriptive term we could give for him? Is it a counting number? No. Is it a whole number? No. Is it an integer? No, it's not an integer because integers can't have decimals, can they? So look at your list of integers. You can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and go on in that direction, or -1, -2, -3, -4. But we can have -7, but we can't have -7.25. So think of whole numbers, and negatives are allowed as well when you're thinking of integers. That's not an integer. Okay. Is that a rational number? Yes, because it is a decimal and it ends. So it's a rational number. And so the real numbers are made up of rational and irrational. Okay, now the way to find these out is to check them out in your calculator. What do we reckon about that? Square root of 3. Let's just look at the square root of 3. All right. I'm going to say that the square root of 3 is irrational because my calculator is taking it to 9 decimals, and there's certainly, so I'm going to guess that that is irrational. And of course, if square root of 3 is irrational, so is the negative square root of 3. Okay. What about this guy? Is that a natural number? No. Is that a whole number? No. Is that an integer? No. Is that a rational number? Yes, because it is written as a fraction there. And they can be positive or negative as well. Okay, so that is a rational number. What about this guy? Oh, well, 0, he's not a natural number, he's not a counting number, but he is a whole number, he is an integer, he is a rational number, he's a real number. Okay. What about this guy? What's the most descriptive we can get with this guy? It's certainly going to be a real number, but can we do better than that? It will be a rational number because the bar over it means it's 0.4545454545 forever. That's what the bar over it means. So it does have an infinite decimal expansion, but there's a pattern to it. Okay. What about that? Is that a natural number? Yes. Aren't they sneaky? What's the square root of 9? It's 3. Yeah, that's sneaky, isn't it? So that's a natural number. So if it's a natural number, it's automatically a whole number. It's automatically an integer. It's automatically a rational number. It's automatically a real number. What about that? It is irrational. Can we get more specific? It's actually a natural number or a counting number. What is 21 divided by 3? It's 7. So yes, it is a rational number, but we can get more specific because 21 divided by 3 is 7. And so that's actually a counting number. Okay, and then what was that? 999. What's that going to be? That's a counting number, which is a natural number. Okay. All right, and so then they've got a set here in the book where they give the answers. And in my math lab, I've got ones like that. And here in this book, they also have a little chart. So the real numbers are everything. Everything is the real numbers. And you can see inside we've got some examples that are natural numbers. Well, all of those natural numbers are whole numbers. They're also integers. They're also considered rational, and they're part of the reals. Okay? Now, whole numbers. 0 is a whole number, but it's not a natural number. But 0 is an integer, and see how it's contained in here. 0 is a rational number. How could you write 0 as a fraction? Well, 0 over any non-zero number. So 0 divided by 7, that gives you the number 0. So I can write 0 as a fraction. So there's that picture in your book, that chart. Okay. So that is a small section on the numbers. I'm going to do 4 operations, if I can find that. Because in my math lab, that's what I have set up for you guys to do next, order of operations. And then I had some exercises on exercise. Let me find order of operations in the index. On page 10. Okay. So on page 10, we have some rules for order of operations. Okay. So if we're grouping symbols, well, let me zoom out. Order of operations. If we have a fraction, for fractions, work the numerator, which is the top, and denominator, which is the bottom, separately first. So this is for fractions. Then, once you've worked out numerator and denominator separately, then follow, is to follow the rules I'm about to do. Okay, so if there are no grouping symbols, so no grouping symbols like a or fractions, so if there's no grouping symbols, then you do things in this order. Step one is to simplify all powers and roots. And work from left to right. Then what takes precedence is multiplication and division. And in the order they come, from left to right. Okay. And then step three is to do any negations. So when you negate something, you change the sign of every term. So if I have -3 plus 1, then to negate that, I'd have +3 minus 1. You change the sign of every term. So do any negations. Additions or subtractions in order. So in the order they come, from left to right. Okay, so whenever we have grouping symbols, parentheses, we do those first. If we don't have any parentheses, no grouping symbols, we do these steps. If you happen to have a fraction, work out the top and the bottom separately, then do these steps. Okay. Now that's a lot of rules, okay? But you'll see these on Facebook a lot. So what do I mean? Surely you guys have seen this kind of thing on Facebook. What number is that? You've seen that on Facebook, haven't you? Yeah, except it'll even be twice as long as that. And they'll ask you, how do you do that? Okay, so let's look at some of these. So let me write them down instead of putting the book on the screen. And I want to keep my rules handy. Let me zoom back out. So let's try. Okay. Now, do I have any grouping symbols? Are there any parentheses in this? No. Okay. Do I have a fraction there? No. Okay, so I'm going to be using these steps. So the first thing I have to attend to is any powers or roots. I do have a power here, don't I? So I have to take care of that first. So let me get my red pen. So that is what has to be done first. So I'm going to copy everything else. And 2 cubed is 2 times 2 times 2. 2 times itself 3 times. So that'll be 8. Okay, so I've done that. Then the next thing it says, do I have any more powers or roots? I don't have any roots, any square roots here, and I don't have any more powers. So I'm not in step 1 anymore. Step 2 says, do any multiplications and divisions in the order they come from left to right. Okay, so going from left to right, I do have a division right there. And so I'm going to do that. 6 divided by 3 is 2. And so I'll write everything as it was. Now this is the expression I'm at. And it says, do any multiplications or divisions in the order they come from left to right. So now going from left to right, that is not a multiplication or division, but I've got a multiplication here. So this is the one I have to do next. I have to take care of multiplication and division. I'm still in step 2 until all of those have been done. So now on the next line, I'm going to have 2 plus, and 8 times 5 is going to be 40. And now this is where I'm at. I don't have any multiplications or divisions. So now I'm going into step 3. Do any negations, additions, or subtractions in the order they come from left to right. And I have 2 plus 40, and that'll give me 42. The answer is 42. Okay. Now, we can, if we put it exactly the way it is, we'll get the answer in our graphing calculator. So 6 divided by 3. So I press the division key, but that little slash comes. Plus 2 cubed, so 2 and then the arrow button here. Then times 5. And if I press enter, I should get 42. Now, why would we want to do this by hand instead of using the calculator? Well, because if it's all numbers, we can do the calculator, but what if it's 6 divided by 3x plus 2x all cubed times 5? You can't do that in a calculator. So this is why we have to know order of operations without a calculator. But it's nice when we're starting something like this, if there's only numbers, you can use the calculator to check. So let's look at some of the other weapons. Let's look at this guy. Okay. Well, we're not going to start straight in with these rules because we have a fraction. And if you have a fraction, work the numerator and denominator separately first. Okay. So the numerator, okay, is going to have, so I use these rules for the numerator, and I do have a power in there, so I'm going to do this guy first. So that's going to be 4 plus 9. So I'm just working the numerator. I'm going to come back and do the denominator, and 4 plus 9 is 13. And the numerator is 13. And now I'm going to do the denominator, just looking at that expression. I don't have any roots or powers. Okay, so I go to step 2, and it says do any multiplications or divisions first. And I do have a multiplication when I'm going left to right. So that's going to be 6 minus 5 times 3, which is 15. And then here's where I'm at with the denominator, and I'm now in step 3. So 6 minus 15 is going to be negative 9. And This is a correct answer. There's nothing wrong with that. Uh, the way you would see it in the back of the book is only one negative sign in either numerator or denominator. They just bring it out. Okay, so 13 over negative 9 is the same as negative 13/9, and that's how they would write it. Okay. If you happen to have, say, negative 13 over negative 9, the negative signs cancel, and then you just have 13/9 if that's the case. But if there's just one, they bring it out. And we've got some whoppers in there. D, doesn't that look fun? If we can do D. All right, D has this fun looking thing. And, well, it's a fraction, so we have to do the top, which is the numerator, and the bottom denominator separately. So I'm actually going to do this on a sheet paper. The numerator is this. Okay. Now, my rules say any grouping symbols, we have to do those first. Okay. I do have a parenthesis there, but there's nothing inside the parenthesis. Like if that had been 1 minus 3 inside that parenthesis, then that would become a negative 2. So what I have to do here is that one first. So that's not grouping, those parentheses aren't grouping more than one term. I have to do that power. Negative 3 all cubed. That's negative 3 times itself 3 times. So you're going to have to put that in parentheses if you put that into your calculator. So and the parentheses are just above the 8 and the 9 buttons. So, and then the negative, we don't want to use a subtraction sign. If it's negative 3, I just want to use a negative symbol. And then up arrow for the power of 3, which will give me negative 27. Because it's negative 3 multiplied by itself 3 times. Negative 3 times negative 3 times negative 3. So that becomes, oops. So what I circled in red becomes negative 27. Now what happens to two negative symbols? They cancel. And what is plus a negative number? It's the same as minus, isn't it? And so now 27 minus 5 is going to give me 22. So that numerator, after doing all of that, is 22. Now the denominator, that's not too bad because this is actually multiplication, even though it wasn't written with a dot. These parentheses are not grouping parentheses, are there? They're used like multiplication. So that would be a grouping parenthesis. We do the inside first. But all of these mean the same thing. They all mean 3 times 5. And so the parentheses being used here as multiplying. So in the denominator, I don't have any powers. And I'd go on to, I don't have any roots. And so I do any multiplications first from left to right. So I do that multiplication first. So that's negative 16, then minus 5 times 3. And so this is coming along for the ride. And then I do that multiplication. So it'll be negative 16 minus 15. And then Negative 16 minus 15 is going to be negative 31. And so my answer for that is going to be negative 22/31. Okay. And again, we could have gotten there with the graphing calculator. The only thing you've got to remember in a fraction, you've got to do the numerator separately. So you have to put it inside parentheses, and then the denominator separately. So let's see how that would go on a calculator. I have to put the complete numerator in parentheses. So let me just move this camera for a second. So in parentheses, so the red parentheses, which I can't do in the two different colors, negative symbol, parenthesis, negative 3, close parenthesis, up to the power of 3, plus parenthesis, negative 5, close parenthesis, then the big red parenthesis for the numerator. Then I hit the division key, and then the entire denominator has to go into parentheses. So parenthesis for the red parenthesis, then 2, parenthesis, negative 8, not the subtraction sign, but the negative symbol. Then the subtraction sign, so minus 5, then parentheses 3, and then close. Oh, no. And then close parentheses for that. It will come back. The lecture period has ended, and now we're going to have the lab. This is how it's been divided up on the schedule. Yes. So we will reconnect in 10 minutes or sooner. So I'm going to email the other campuses. I should have mentioned that before. We will reconnect in 10 minutes. All right. Okay. I'll be there in a sec. Let me send them an email. So Kayla and Ashley and Yolanda. Class not over. Just taking a break between scheduling. The DL will reconnect in 10 minutes. Students are not to go home. Okay. But we don't have long to go now. No? No. Okay. No, everyone comes which will be annoying, but at least your mom will be fresh. Well, I wonder. Yeah. All right. Let me
Yeah, I'll just wait until they get back. Oh, excuse me. Okay, and let me get Banner up here.